Can I start?
Yes, you can.
Okay, so hello everyone. This is my artificial neural networks project. My name is Anas Nadir. This is a brief dataset overview. This dataset was created by computer science students, I believe in the University of Harvard, throughout 1 year with help of resource donations from Google and big companies, which can be found in their website, respective website. The dataset used is a binary classification dataset. It contains 215 binary features and 3,799 samples. I'm going to show a screenshot of the dataset later. This dataset is basically an Android malware dataset. It attempts to predict an Android APK file's nature by extracting its features and deciding to which class it belongs. It uses S for malware, B for benign. And personally, this was a very interesting dataset because Android malware and Android security is my area of interest. This is our dataset. In the column names, I took this screenshot from Linux using Leafpad. That's why it's not well organized, but it shows my point. So above the features, each column addresses either an intent in the Android APK file or an API call, the existence or not. I mean, the intent or API call or the permission, Android manifest permission. So those all the features they are like this. And I wanted to point out the dataset imbalance. We have 2,539 benign, 1,260 malware. The column which contains benign or malware is actually I forgot the name, but I can say like categorical name column or something like this. It doesn't have a 0 or 1, but it needs to be manipulated later. So first of all comes the pre-processing of data. So first I had to convert the last column of my dataset to two classes, which will signify binary classes because two states, 0 or 1. So I converted the class S malware to 1 and class B9 to 0. I showed the code snippet. Also in this presentation, I tried to use as much figures, as much tables, and as much details. I tried to add them. I mean, I tried to add as much as was requested as possible. So I split, that's why I'm using code snippets. So I split the data set to 80% train set, 10% validation, 10% testing set as the project document asked from us. So we can see from the code the way I'm using. So I'm just first of all getting the test set, then using the same training set that I got and getting 10% of it again to get the valid, Y valid, X valid, X train, Y train, and X test, Y test. And then I shall address the accuracy metrics that I used and early stopping callback and batch size, weight initialization, etc. I could not include all code in here because it's gonna take me 50 slides. So I know we need efficiency for time. That's why I try to show the most important parts. I don't show, for example, the imports, etc. So we can see here I am using Keras initializers random uniform in the array -1, 1, as was asked from us. I'm using a sequential model. I'm using one hidden layer, 25 hidden units, 215 features. Hidden activation function is ReLU. The one output with one neuron and activation as sigmoid, which means the output will be either 0 or 1. It's mapped like this. If the model's output is negative, which means 0, which means benign. If it's positive, which means 1. That's how sigmoid works, as I saw from the project file. And later I'm using the optimizer, which is the standard one which you are using. This coding file is showing the general coding file. As we can see, I am including some comments. We can see that we can just comment out. For example, if we comment out momentum and decay and Nesterov equal true, we are addressing question 1B, 1A, B, and C. If we go to D, it's same. Learning rate is same. Just learning rate. If we go to E, we add, I believe, decay. If we go to F, we add momentum. So this in here, I want to say just this is the general file I'm using just to have a better understanding, or not understanding, like overview of my code. So I am using binary cross entropy loss function optimizer. I already mentioned. Metrics, I used all the ones which were asked. The binary accuracy on the validation set. The Keras binary accuracy will be used later with I just want to mention the Keras.metric binary accuracy will be retrieved later when I use model.evaluate to get the accuracy, final accuracy, I mean after training the model, etc. So binary accuracy and Keras metrics precision, as was asked from us, recall, F1 measure, and area under curve. And then I am using early stopping callback. I am monitoring validation loss. The mode is minimum, detecting if the validation loss is increasing in a certain patient's range. In here it's 100. For the patients, I researched so much about this, and everyone recommends using 10% of the epochs. 10% of the epochs. This code file, I was using 1,000 epochs because I was since the resources are available, I was trying to achieve very high accuracy, and I was able to do this. I'm gonna show later. And I am restoring the best weights once the early stopping happens. The best weights are restored in the model, and then yeah, it's working. The batch size is 25. Validation data, as you can see, callback is just input in there, and variables I want to show the outputs. I mean, see the outputs in the command line, and later we can see the evaluation. But as I said, I didn't include here, but everything is included in the files separately and commented, and hopefully everything is clear. So the question one, for the first part, it was implemented in the files. For part B and C. After implementing the model with early stopping plot, in here there is no decay, there is no momentum. In here there is just learning rate, and I am monitoring all metrics which were asked from me, and I'm using. First of all, I used 100 epochs. Then I see the validation loss can still go even further. To elaborate my point, validation loss. Gets for my training for this project, it gets very close, even lower than 1. It gets to 0.9, 0.8, 0.7, 0.6, something like this. But I can see that it can still go more. That's what shows here. In the left is the 500 epochs. It shows that it didn't stop, as we can see. It just keeps going, even it reached 500. I got those accuracy metrics. I agree they are very high. I suspect this was because of the dataset. The dataset was very well organized. I later confirmed this fact from Weka. I'm gonna. I just wanna say, Ojam, these values are correct because I later confirmed from Weka. I'm gonna show using 8 different classification methods later. I'm gonna show also later. So we can see from the 500 epochs, it did not, of course it's converging because it's going even lower than 0.1, and it seems not going up, but it didn't do early stopping, which means the validation loss can still go even lower, So based on this, I got these accuracies and this precision. Also, I researched on precision. What does this mean? for precision for false positive recall, for false negative. F1 score is the harmonic mean for the precision and recall. Area under curve is how much of the how many elements of the data set are included under the curve. So the values are really high. But as I said, we can still get one much better. And I used 1000. So when using 1000, just changing the 1000 and keeping everything same, learning rate is 0.01. I could get accuracy as 99.7. I'm sorry, I didn't convert them to percentage, but I think it's in here. It's much better because I want to see the change even in the smallest index, not index, but for example, order of 1,000, 1 million, 1 billion, something like this. I want to see the change there because I'm interested in this data set. I want something that works very nice. So we can see from the 1000, the accuracies are really high. And this is even without using the further improvements, which are the decay, for momentum, scaling. I'm gonna also mention all of them in detail.
Can you go one slide back?
This slide.
So do you shuffle the data sets each time in each epoch? Maybe it's...
The data set is done, as I read, is done automatically.
Yeah, probably Keras does that automatically.
Yes. I didn't include the import stuff because it's gonna take much more space, but it's done automatically.
And okay, just a second.
Okay.
So you said you are optimizing validation loss for early stopping.
Yes.
And okay. Now in question 1b, you train the network using so the optimum number of epochs is 500 for the first case.
Actually, as I understand, the optimum number of epochs is the epoch that's early stopping happens in, right?
Yes, but you said it didn't.
Yeah, that's what I said. So it didn't. That's why I even increased further, and in a weird way, it stops at around 3. I could include the epochs like numbers exactly, but these curves show much more accurately. It stopped, yeah. When using 1000, it stopped. For 100, same thing. It doesn't stop. Just keeps decreasing. You can see that it keeps decreasing.
It's interesting. It stops at 350 when you set the max epochs to 1000, but doesn't do the same when you set it to 500.
Yeah. What's more interesting is the D part. I'm gonna also show. So
okay,
can I go on?
Just a second. So you restore the best weights, right? For the optimum.
Yes, we can. Yeah.
Okay.
Restore best weights equal to.
And then you train the network using, and then you computed predictions using the best weights. That's what I understand.
Exactly. That part of doing the model evaluation is later, which can be seen on the code. I didn't include here for the space, for the available space, also the time.
But okay, we'll come to that. Now we can go to question 1c. So okay, you computed predictions on test samples and reported accuracy, precision, recall, F1 measure, under RSC curve score, and question 1D. Maybe we can continue with question 1D, where you were supposed to repeat.
Okay. So in here So in here I am repeating the program, and using 1000 epochs because I found this the best one. And I am reporting the accuracies 10 times and reporting the optimum epochs also 10 times. We can see here the standard deviation is very small. The mean also is around 98%. The maximum is I made a mistake here. The maximum is 99,736, not 90. So sorry for that. I just see it. I just seen it. So yeah, these are very. I know these are very high values, but as I said, I'm gonna confirm later in question 5, where I do literature review.
Now, did you notice any change in the optimum number of epochs when you repeat it 10 times? Oh, you already
yeah.
okay. You have a table. I didn't see it. Sorry.
No problem. In the next slide, Ajam, I show all the plots 10 times. It can be much clearer, but yeah, whatever you want me to do.
You can go to the next slide.
Okay, so in here, I found the best representation. Of course, this table is nice enough, but if we use the curve, we can see it, how does the value loss decrease, etc. So these are the changes 10 times. Training loss versus validation loss, all the plots. And we can see sometimes the validation loss is way off. Sometimes it's really nice, going even further, even much lower than 0.1, as you can see from here. It's all the time close to 0.1, but the way the model is implemented, the validation loss, it doesn't fluctuate so much. It's really minimized, the maximum between 0.2, 0.1, and even less, 0.09, 0.08, 0.0. And using the further methods, it's really, we will see that it will even go less and less and less.
Okay. Question 1E.
Okay. So question 1E, in here, I implemented the decay, as we saw from, sorry for going back. In here, this I uncommented the decay and commented everything else, and got this. This is training versus validation loss. These are the metrics. Question A, we were asked to repeat part A and B and C, I think. So I repeat them and got the plot and got the metrics with accuracies. The accuracy, we can see it's higher. That's why I said I didn't change to the order. I mean, I didn't make it times 100 because I wanted to see like the maximum order of number. We can see here before just learning rate, maximum is 99. Yeah. So I think this is what was asked from question A. Just uncommenting the part and executing gave me this.
Okay. What about next one?
So question F, in here we were asked again to implement momentum coefficient. I am just coming here and uncommenting this for the momentum, I mean, and sorry for this. And I got even better, we can see here, even better. It's even lower than 0.05. Accuracy is maximum, as I said, and even epochs are much more efficient. Epochs are 308. If we remember from using just learning rate, it was around close to 350 with 1000 epochs. Now it's 308, so I think this is the good, a good way of improvement. Also, the area under curve is covering maximum number of elements in dataset. F1 score, the false positive are minimized. And Hojam, do you listen to the Adhan? I don't know, does it reach you or?
Yeah, I hear.
Yeah, that's better, yeah. Because I'm living close to a mosque. I'm gonna try going further. Sorry for
We
it.
can hear you. Maybe you can continue.
It's not a problem. I'm trying to find some place where it doesn't hear. Okay. Sorry for this. Oh, I was saying the validation loss is even lower now, lower than 0.05. Accuracy is the maximum number ever reached, and epochs is the minimum one. This one is like the most minimum epoch with the highest accuracy. So this is really interesting and really important, I think. Yeah. So should I go further?
But you said the optimum number of epochs is 250.
Yes, Sojan, but it's 350 for the
Or 350.
without just learning rate, just learning rate. But in here in F, in E it's learning decay. In F it's with momentum. So optimum epochs decrease even more.
But in
Because
part 1D, when you repeat 10 times, the optimum number of epochs, I see sometimes higher, sometimes lower.
yeah,
Okay.
John, for the way I thought about it is, what's the optimum number of epochs is the minimum number of epochs with the highest accuracy. That's how I thought about it. Also, this causes early stopping. What?
That's okay, okay.
Yeah. So also this causes early stopping. As we can see, the curve is stopped, and the accuracy is the highest possible until now. So in question D, this is just using learning rate. That's why we can see this is very high. Okay, what? 343. So much more steps. That's how I thought about it.
So yeah, in general, it's higher. That's what I can see from the table.
Yeah.
Okay.
Again, it's higher. It's higher when we are using only the learning rate.
Yeah.
But using the momentum, it's lower. It's like more efficient. Yeah. Okay.
Okay.
So
1G.
1G. So 1G is repeating everything. So as I said, after implementing the model with early stopping and retrieving all the metrics and using n epochs 500 to 1000, this time with scaled inputs. We can see from my codes. Did I include? I will show later, I think. Yeah, I forgot to show the code snippet, but in here I'm using scaling as I scale the inputs. The way I'm using scaling is I'm doing the same division in here, same getting test training set 80%, test 10%, validation 10%. Then I'm using the standard scaler from I think sklearn, and I am fitting and transforming the X train, and then I am transforming the X validation, and then X test. Yeah.
Okay, that's what we expected.
Okay, so
repeating 1B.
Yeah, G, B, and C, because B is implementation, C is actual prediction. So we can see here the validation and training set. It causes some fluctuation, some zigzagging. More or less, this is even lower than 0.1. It's, I think, even better. In here, since this is just B and C, I'm just using learning rate. I didn't include momentum and learning decay. And I could get these accuracies. These accuracies are acceptable for now because nothing else is included. No learning decay, and no momentum for now. So I got all the metrics that were asked from B and C. Should I go on?
Just a second. Okay, did you repeat part 1D?
Of course, yeah. So this is part D with the scaled inputs. We can see from here the highest accuracy as maximum. I am sorry again. This was the highest, 994. I used 992. Unfortunately, it's just typing mistake. These are the optimum epochs. We can see a significant drop in the optimum epochs. Since I'm using 1000 epochs, these optimum epochs use a patience of 100, which means this stops if the val loss variable doesn't decrease in 100 times. So yeah, so it's pretty interesting. There is a very significant drop as compared to the first one. The first one was 300, 400 optimal number of epochs. So this table reports both of them, accuracies and optimal number of epochs. Each optimal number of epochs corresponds to accuracy, which means the model stops in 227. Whatever the weights it got, the model is evaluated and with test set, and this accuracy is generated. Also, I included 10 graphs for each individual ones. This process was kind of time consuming, but I think it's much better to have graphs along with the tables. We can see the change. We can see here as we are changing. Sometimes the results are very interesting. It gets so much close to zero. Sometimes even reaching 0. 0. Very low, like 0.05 or something. And yeah, these are the 10 ones, sometimes zigzagging sometimes, but all the time it's really conversion. It's going lower than 0.01. Most of the time it's lower than 0.01. Sometimes perfect, sometimes not perfect. Yeah. So since I am using a fixed learning rate, that's I think the issue. And the change of the accuracies is due to the initialization methods, which is using random uniform. So every time the weights are generated randomly, which means it can, as far as I understand, it can reach a local minima and think that's the minimum possible, but it ignores a global minima, for example, as we know from the course. I hope I am correct. So yeah. So yeah. So should I go on, Ojo?
One thing I can ask is, in the previous slide, you show the maximum number of epochs. Sorry, the optimum. Do you compute those using a code, right?
I'm computing them using the early stopping. The same callback, the same early stopping callback.
Yeah, but I mean, the code, you have a code that computes that, right?
Yes, of course, it prints them.
Okay. Now, we can continue with repeating part 1E.
1E. So in 1E, after implementing learning decay along with the scale inputs, the accuracy is more or less, interestingly, not that much high. I mean, relatively to the others. This is a change which is in order of, I think, 100. So it's 0.99, 0.98 or something. So yeah, so in here I uncomment the learning decay part and use it with scaled inputs, and I get this kind of plot. Yeah, as we will see later, it can go even lower. I think it will go even lower. The goal here is to really improve it as much as possible. Yeah, with the momentum,
Okay.
we will see. So yeah, this is repetition of part B because E is repetition of part B and C. So this is repetition of part B, this is repetition of part C, reporting all the accuracies.
Yeah.
etc. Yeah.
Okay.
So
next one.
So the F part. F part is momentum. Momentum is always used. I forgot to say momentum is used as 0.5, as was asked from us from the project document. We can see it's better indeed. Indeed, it's better. This time the curve of the validation goes even lower. I know these changes are not that much significant, but since I'm getting very high values, I am trying to improve as much as possible. So we can see the validation curve. Sorry, the validation curve gets even lower, the green one. And yeah, this since F is repetition of part B, A, B, and C, I am doing this for B and this for C. These are the accuracies. There is improvement in the order of 1000s, I think. These are everything: the F1 score, recall precision, area under curve. Yeah.
Okay, just a second. So what happens to the optimum number of epochs?
We can see it decreases. As I said, I could include. Sorry for interrupting. I could include the exact number, but the curve shows much better. Around 235. There is early stoppage. You can see.
Mm-hmm.
Yeah. So optimum number of epochs is around 235, as we can see from the curve.
Okay, when you compare this to repeating part C and E.
I couldn't understand.
Sorry. Okay. If you compare the accuracy, so the accuracy is 98.94.
Yeah.
What was if you compare it to repeating part C and E?
It's a very small improvement in the order of thousands. For example, 989. This is 986. This is 981. So B and C and E. F is the best one, but at the order of thousands. So it's 169, like that.
Okay. And if you compare number of epochs for like the parts B, D, E, and F.
For G, you mean? For G, you mean?
Yeah, within G,
yeah.
Comparing B, D, E, F.
Yeah, for the optimum number of epochs, the B and C are very close to F. Very, very close.
Okay.
Very close. And for E, it's less. Less than, yeah, the E is high.
Okay, that makes sense.
Yeah.
But in general, if you compare it, okay. So when you compare the accuracy when normalized data is used.
Hocam, I'm gonna comment on that also because as I show my data set, the features are 0 and 1 already.
Yeah.
So standard scaling or min-max scaling, making the features between 0 and 1 is already done. So from my experience, it's kind of messes up the accuracies, because when I used without, as I showed from the first slide, it can even reach 99.7, for example.
Yeah, it's better.
But yeah, with standard scaling is 989, which is a little bit less. So it's better not to use standard scaling, in my opinion. Yeah.
Okay, that makes sense basically.
Yeah.
Okay. Okay, let me check one thing in my documents. S1G.
Anas?
Yes.
Okay.
Is those values from test set? I just want to time step part.
Yes, that's it. I get those values after I use model.evaluate.
Right, thank you.
All right, now let's continue with the next question. Question 2.
Okay, so this is question 2. I implemented everything that was asked. Maximum number of epochs, the hidden neurons, the batch size, learning rate, initial learning rate, decay, momentum, regularization factor, and weight initializer. This part was the most resource consuming and time consuming from the whole project. I used the same implementation as question 1. Now I am adding parameter grid. I got this from sklearn. I'm gonna show also the code for it. I got this from sklearn.model selection. And I just use all of this and input to the parameter grid, and have each parameter have these values, these kind of values, and test and just run the whole program and keep track of the accuracy. I'm gonna show you. Okay, so here it's showing my point. So I'm using parameter grid for all of them. Regularization is named as lambda, just for simplicity, simplicity goals or something. Alpha is the momentum. Yeah, and all of them are in here. So in here I just get all of them. I'm using the same model. I'm using the basically I just replaced the place where I was using fixed inputs. I'm using no parameters in a grid. In the grid I got, as you can see, grid equal parameter grid, parameter grid. So I just input everything, and for the decay I had a problem. It had 0.0 and learning rate over max and epochs. I could not implement this as a definition. I did it later. I did it in a alternative way. The way I did it is I have a decay as a 0 and I have 1. And in the code, I check if decay is 1. I say I'm commenting here. In case second choice, which is 1, was chosen, new decay is calculated as learning rate over max number of epochs. So I'm just modifying the decay here. Yeah. Otherwise, everything is implemented. Yeah, everything is implemented. Yeah.
Okay, can I see the code again?
For the initializer, I used like this. I used uniform and I used Lecun uniform. So
You used the train set and validation set to optimize the parameters.
exactly, yes. And early stopping is also basically everything is same in here as question 1. Even there is a separate file, coding file, but everything is same. So I'm using training set and validation set to get the optimal number of epochs and get the best set of weights, and then go into the test model and testing with the highest weights and get the accuracy. And I don't know, did I show? No, I didn't show. After I do this, I'm defining an array parameters dot dash list. This array keeps record of all of these parameters slash and the accuracy I got from the model.evaluate. So I am keeping this is for part A. I am keeping the record of everything, and the accuracy get the highest accuracy. Not highest accuracy, I mean just accuracy in the parameters. After this parameter searching, grid searching is done, I am then looking for the row with the highest accuracy and then doing part B, which is using the optimized hyperparameter.
Did you repeat training 10 times for each hyperparameter combination?
Actually, Hocam, the way I did it is it's getting a combination and executing it, recording the parameters list accuracy, and again and again and again. I think it's much more than 10 times.
No, I mean, for each combination, you were asked to repeat 10 times as well.
For each specific one?
Yeah.
No, I didn't. I didn't see that part. I thought we just need to get parameters and combine them, test, then again combine, test, combine, test. It seems, yeah.
Okay, you said you are still doing early stopping.
Yeah, for now everything is same as question 1, including everything, yeah. Basically same model, but with the same model with non-fixed inputs. So I'm just using from parameters in the grid. Already this takes this process took several days because I was getting some mistakes, some errors. I was sometimes just running it and going to sleep, waking up and finding it. It's done. Sometimes it takes more than 3 hours, more than 4 hours, more than 6 hours, even with the resources of the workstation. But I managed to get some to get the output.
I mean, in your case, you have more than 100, I think 200 features and
215, yeah.
Also thousands of samples.
Yeah.
You could reduce the parameter grid, like.
Yes, John. I could reduce it, but I didn't want to because I really wanted to find if it's possible to minimize the validation loss even lower. I just wanted to find out. That's why I tried to use everything that was given.
And so you said you did grid search?
Yeah, using the sklearn parameter grid.
Okay. And what is the optimum parameter configuration you found?
That's the part B, and it's here. So this is the optimum I found. learning rate 0.01, decay 0.0001, batch size 25, hidden units 150, max epoch 100, momentum 0.1, initializer random uniform, and the regularization 0.01.
Okay.
Yeah.
Do you have any plot? Okay, you have the plot.
Of course, I have the plot because you were asked to do this. We can see this is much smoother. Even there is a problem here because the validation loss starts from a very high number, but it really gets even like lower than 0.0549. We can see from the code. It's printed in the code. In the curve, it can really see this is proper convergence. It's going to very close to 0, and it's early stopped at around 98 with those parameters. We can see here, this it doesn't need 500 anymore or 1000 anymore. It just needs 98, for example, and a very high accuracy. Even 98 steps, much less steps, but very high accuracy. That's why I chose to keep all of them. Even it takes very much time and resources from the workstation, but I could achieve this kind of result. Yeah.
Okay, that's nice. What about question 3?
Question 3. So I chose 5 optimizers. I'm gonna talk about their parameters, etc. I chose Adam, RMS prop, ADMax, ADAData, ADAGrade. We were asked to choose at least 3. I tried to go even further to choose because I wanted to even get like a very nice, very high accuracy. I need to say that for the question 2, I got these parameters. In order to get these parameters, you need, I mean, for me, for my personal case, my personal dataset, you need many hours. I didn't even record. I just, for example, sleep and wake up 8 hours later and find it's done. So I thought it's more than 3 hours. So since I got these kind of optimum parameters, I had the idea of using them directly for the question 3 and question 4. There is no need to do from the beginning for each optimizer. For example, in my case, 5 optimizers, and it's the order of probably it's gonna take 1 week, I think. Even I know the workstation is very powerful. That was my reason. I need to state that. So I'm using this optimum number 0.01. They had some other parameters, but since I don't have them in the parameter optimization, I thought I can just keep them in their default value. I thought there is no need to tweak them because they were not part of the hyperparameters we were asked to tweak. Yeah, exactly this. So I got all of them from Keras optimizer, etc. I'm gonna show each one in detail later. I need to mention before that Adam, this first one, as I read from the literature review, it's the best one for my kind of binary classification, especially combined with the kind of features I used, which are also using binary features. For example, either intent exists or not exists, either API call exists or not exists, either permission exists or not exists. They said Adam is the best one, and I confirmed that later from my own testing. Yeah. So in here, since question 3 was repeating 2A and I think 2A and 2B, if I'm correct, we can see here the kind of train loss versus validation loss and accuracy metrics for the 2B, I think. So for Adam, as predicted, we will see from later, Adam will get the highest one, 0.992. This is the highest one I can get. Training and validation is extremely fast, and epochs are extremely small compared to others. We cannot compare 500 and 192 to 28, for example. So this was a very interesting output. Yeah. So it reaches conversions almost linearly. You can see that just the line goes directly to conversions. Although it starts from a fairly significant validation loss, val loss variable, it gets down very how can I say, very fast. Yeah. And the validation loss now is even further less. In here, it was reaching 0.0, 0.03, 0. Even lower. This kind of plot, since it's showing from 0 to 30, this is maybe not properly shown. But if we zoom on the graph, we will see what I mean.
It's okay. So, we don't have to comment too much on the graphs for this question. And also, actually, I probably forgot to state that you should repeat question 2b in question 3. But I mean, you obtained test accuracy for this question as well, which is good. And you also obtained the plots. So therefore, since I didn't specify it exactly, I thought some of you may not do test evaluation for question 3, and therefore I may exclude it from the grading. But those who did it, maybe, I don't know, I can consider that as well. But it's okay. I mean, it's good. But on the other hand, when you use the same default parameters as in question 2, usually, I mean, if you change the optimizer, the standard technique will be to repeat the optimization for those parameters as well. I also didn't state that explicitly. I mean, I realized that I didn't state that explicitly in the document. So it's okay, but I just maybe expected you to optimize the hyperparameters of each of these optimizers. So maybe you can continue with the next slide, and we can just quickly take a look at the accuracy measures. Can you go to the next slide?
Yeah, so this is 992, this is 986, this is 984, this is 905. This is the worst one. Ada delta is the worst one. Ada max is kind of perfect. And adequate.
Okay, looks like the best one is ADAM for the time being.
Yeah, the best one is there. Yeah.
Okay, let's continue with the next question.
Question 4. So, we were asked to add 2 and 3 hidden layers. So I start from 100 epochs along with the optimum hyperparameters. This one also I got from question 2. Like you said, Hocam, it wasn't specified, so I thought I don't need to wait another 8 hours or something. I just need to get the optimum hyperparameters, and indeed it gets a highest accuracy. I think this is the highest accuracy possible. 9973, and a nice curve, getting the val loss at very insignificant values, 0.02, 0.01, like that. But early stopping did not happen, so I thought let's increase number of epochs. This is for 2 hidden layers. These are the accuracies I got. This is for 2A, this is for 2B. So I increased hidden layers to 500 epochs. And I got same. No, not kind of same accuracy, but faster conversions. We can see here, faster conversions. But again, there was no early stopping. which means the value loss can still decrease more. So I thought let's increase even more. So I went to 1,000 epochs, and I got this is as the highest accuracy ever. I got 9947. All the previous one were actually I made a mistake. This is 997. This is 994. Yeah. So kind of conversions, and yeah, this comment is mistyped, but it's very high accuracy.
Maybe it starts overfitting. That's fine. You can continue. I mean,
probably, yeah.
This type of analysis is not necessary for this question.
Okay, so 2,000 epochs. I go here.
Yeah, you started
finally
overfitting.
Yeah. So that's what happened.
Okay.
So now
what about 3 layers?
Yeah. So I went directly to 1,000 epochs, and I got this kind of accuracy. And
okay.
this one, yeah.
Yeah, you can continue to the next question. I think this is enough for this question.
Okay. So the next question, I got my data set from this website, and as they said, they test their data set with a new input, not doing cross-validation. This is an important point. As they got this best accuracy as 79 and worst as 20.2. But my accuracy using cross-validation and test split and validation split, but they use like typical outdated model. This analysis was done in 2010. My accuracy, as we saw, can reach even 99%, and minimum of 97, 96, around like this, and a very high accuracy and very insignificant validation loss. And I mentioned before, I wanted to see if this kind of values, am I doing something wrong with my code? I implemented this in Weka, implemented dataset in Weka, and tested on 8 different models. All of these are classification methods using 0R, naive Bayes logistic, ABK, trees, G48, random forest, and we can see that indeed it gets very high accuracies. This is using tenfold cross validation, except this rules.2a, which gets 66%. So yeah, and that's it.
All right, thank you very much for this nice presentation.